Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we will be discussing the solution of a problem from the section Analysis, and it talks about the nature of sequences. And this question is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 704104. This question is suitable for all these examinations. Right. The given question is: consider the sequence an, a suffix n, n greater than or equal to 1, and bn, n greater than or equal to 1, defined by an is equal to e power n plus e power minus n whole by 2, and bn is equal to an plus 1 by an. Which of the following statements is true? We are given 4 options. Option 1. For each x belongs to R, there exists an n such that an is greater than x. Option 2. For each x belongs to R, there exists an n such that an less than x. Options 3 and 4 are same options as the options 1 and 2, limited to bn instead of an. Right. Let's now discuss the solution of the problem in detail. So we consider 2 cases. In the first case, we talk about the sequence an. In the second case, we talk about the sequence bn. So we have the sequence an, n greater than or equal to 1, where an is given by e power n plus e power minus n by 2, n belongs to n. Right. It's very clear. E power n is always positive for all values of n. And therefore an is positive for all n belongs to n. Right. And let us talk about the limit n tends to infinity of an. That is equal to limit n tends to infinity of e power n plus e power minus n by 2. Take out 1 by 2. Limit n tends to infinity of e power n plus e power minus n is 1 by e power n. And you know, limit n tends to infinity of 1 by e power n, e tends to 0. And thereby we are left with 1 by 2 into limit n tends to infinity of e power n, which does not exist. Many people say it tends to infinity or is equal to infinity. But in the right terms, it says 1 by 2 limit n tends to infinity e power n does not exist. Now every term an is positive for all n belongs to n, and limit n tends to an does not exist. Both these 2 things will tell you that that it is divergent and diverges to plus infinity. And it is by definition limit n tends to infinity of an is plus infinity. Let's call the definition of limit n tends to an is equal to plus infinity. From the definition, limit n tends to an is plus infinity if and only if for each r greater than 0, for every positive real number, there exists a natural number capital N such that a n is greater than r for all n greater than or equal to n. Now look here, each a n is positive, therefore we can rephrase this definition. Instead of for each r greater than 0, we get for each r, for each real number r. Because when r is negative, automatically this is bigger than r you will get, because every an is positive. So, since each an is positive, the above definition can be rephrased as limit n tends to an is equal to plus infinity if and only if for each real number r there exists a natural number such that a n is greater than r for all n greater than or equal to capital N. Now let's call the option 1. For each x belongs to r, there exists an n such that a n greater than x. Not only one x, there exists one n, but there exists infinitely many n's. You can see now by the above. Now limit n tends to infinity of a n is equal to plus infinity implies from the above, instead of r capital R, he has given x. For each x belongs to r, there exists a natural number such that a n is greater than x for all n greater than or equal to n. Not only one n that you get infinitely many n's. Right. Thus the option 1 is true. And the option 2, let's call the option 2 and right. So it is a question from the section B. There will be only one correct answer, and that answer is option 1. So the answer to this question is option 1, and you need not go for the remaining options. This is as far as the examination is concerned. But we want to know how the other options are not true. Let's call on the next option, option 2. For each x belongs to R, there exists an n such that a n is less than x. So this is not true. If suppose you take x is 0, a n is less than 0. Is a n negative for any n? No. A n is positive for all n. Therefore, this is not at all true. Not at all true. So, for x is equal to 0, there does not exist an n such that a n is less than x, where x is 0. So, a n is negative. This is not true, since a n is greater than 0 for all n belongs to n. Therefore, option 2 is not true. We need not wait to discuss option 2 this long. So the moment we have seen that a n is positive for all n belongs to n, there itself we call option 2 and say this is not true. Anyway, let's move to the next slide for the second case, where we talk about the sequence Bn n greater than or equal to 1. Right. We have the sequence Bn n greater than or equal to 1, where Bn is an plus 1 by an, n belongs to n. And we have already seen an greater than 0 for all n belongs to n. Therefore, Bn is also greater than 0 for all n belongs to n. Right. Now limit n tends to Bn is limit n tends to an plus 1 by an. That is equal to limit n tends to an e to the power of n plus 1 plus e to the power of minus n plus 1 by 2 by e power n plus e power minus n by 2. That by 2 will cancel, and you will get this one. Now take in the numerator, take e power minus n plus 1 common. In the denominator, you take e power minus n and write down. So that will be limit n tends to e power minus n plus 1 into in brackets e to the power of 2n plus 2 plus 1 whole by e power minus n in brackets e power 2n plus 1. and some cancellation takes place, and you will get 1 by e power minus n plus 1 by e power minus n. When cancellation takes place, it will be 1 by e. Limit n tends to infinity of numerator by denominator. And limit n tends to infinity of the numerator is infinity, tending to infinity, and the limit n tends to infinity of denominator also tending to infinity. Therefore, it takes an infinity by infinity form, which is an indeterminate form. To evaluate such indeterminate forms, we use L'Hopital's rule. That's what I have written, LHR, the so-called L'Hopital's rule. That is, you take the numerator, differentiate, and take the denominator and differentiate, then take the limit. So that will be 1 by e into limit n tends to infinity of the differentiation of the numerator is 2 e to the power of 2n plus 2 by derivative of the denominator is 2 e to the power of 2n. So after cancellation, and then we will get 1 by e into e square, that is equal to e. That means the sequence Bn is convergent and converges to E. So the sequence Bn is convergent and converges to E. Right. We call on option 3. For each x belongs to R, there exists an n such that Bn greater than x. Now, if you say this option is true, since Bn greater than 0 for all n belongs to n, and you say that the option 3 is true, these two put together will give you that the sequence is divergent and diverges to plus infinity. So if option 3 is true, then limit n tends to Bn is plus infinity, because each Bn is positive for all n belongs to n. And this leads to a contradiction. Why? We have seen above that the sequence Bn is convergent and converges to E. So therefore, this contradiction will tell you that your assumption that option 3 is true is not true, is false. Therefore, option 3 is not true. Option 4 is also not true. Why? For each x belongs to R, there exists an n such that Bn less than x. So if you take, and now we have already observed Bn is positive for all n belongs to n. And this is the case for each x belongs to R. We take the situation when x is equal to 0. Then does there exist an n such that Bn less than 0? That is, Bn is negative? No. Bn is positive for all n belongs to n. Therefore, this is not true. So, for x is equal to 0, there does not exist an n such that Bn is less than x is equal to 0. That is, Bn is negative. Since this does not exist, because since Bn is positive for all n belongs to n. Thus, option 4 is not true. Summarizing all the options, the answer to this question is option 1. So that is the detailed discussion of the solution of the given problem. And this is in a way, a very easy question, provided you know the definition of a sequence diverging to plus infinity. Right? Then you have to argue systematically, logically. It is definitely not a difficult question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will definitely meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.